Boys and girls, we are back. Flipped geometry with Miss Robbins and Mr. Llanos. And once again, Miss Robbins is not here. I don't know why. Go ask her. Ask her why she's afraid to do one of these videos. I'm not sure what it is. You find out. You get back to me. Anyway, we're going to get right into it. Polygons, quadrilaterals. Okay, we learned these two terms way back at the beginning of first semester, but just like we did triangles, we are going to cut these things wide open and just do a whole bunch of different things with them. But before we do, I need you to follow a few steps that are going to make this video just that much better for you in learning what it is that we're going to be doing in class. Step 1, get your notes out. Step 2, turn the page. Step 3, direct your attention to where it says Interior Angles Sum. Step 4, use a pencil, not a pen. Now that you've got your packet to the right place and you have a pencil to use, I would like for you to direct your attention to this chart here. We are going to fill this out. Actually, I'm going to get you started in filling it out, and I would like for you to do the rest of it on your own. That's why I want you to use a pencil. Just in case you mess up a little bit, you can erase those answers and put the correct ones in. So I want you to take a notice at each column is the same. Each row, there are 5 columns in each row we're going to fill out. I'm going to fill out just 3 of them for you. The first one is triangle. You've got a picture of it. You're going to fill in the number of sides for a triangle. Then the number of triangles column is the one that I want you to take a look at. We're going to divide each polygon into triangles. Okay, and then using that number, we're going to determine what the sum of the interior angles is. So let's start with this polygon. Okay, we know it's a triangle. A triangle has 3 sides. Now, how many triangles can we divide this polygon into by drawing segments from one vertex to another one that is not a consecutive vertex? Let me show you what I mean. Let's begin with this vertex down here in the lower right hand corner. Now, both of the other vertices in this triangle are consecutive vertices. Let me show you. Let's take this segment that I've already drawn and start from that vertex. There isn't another vertex in this triangle that we can divide it, that we can join it to that will divide it into another triangle, because look, that's a side right there, and let me grab this guy again. This is also a side here. So we can't divide it into any other triangles. Now, the last column says, what is the the sum of the interior angles? Again, we've known from earlier lessons that the sum of the interior angles of a triangle is 180 degrees. We can begin to fill out our chart for the triangle row. We know it has 3 sides, only one triangle within that triangle, and the sum of the interior angles is 180 degrees. The next polygon we're going to look at is a quadrilateral, which we know has 4 sides. Now, if we were to try to do the same thing we just tried with a triangle, and what I mean by that is to divide this polygon into smaller triangles by drawing segments from one vertex to another one that is not consecutive, we could see that we can only do this one time, which divides this quadrilateral into 2 triangles. We can fill out our chart now. 4 sides for a quadrilateral. We divided it into 2 triangles, and because each one of those triangles has a sum of 180, 2 times 180 is 360. Now, what I would like for you to do is fill out the rest of this chart on your own. You will soon see a pattern start to form. I've intentionally not included the pictures for some of the polygons so you can figure out the pattern by using the numbers in the chart. Now, if you turn the page and look towards the middle, you will see where it says exterior angles sum. To the right of that, you can read exterior angles are always supplementary to their adjacent interior angle, which means supplementary, of course, which means they equal 180 degrees. Now, there are 4 examples here: triangle, quadrilateral, pentagon, and hexagon. I'm going to actually walk you through the triangle example, and I would like for you to try the other 3 on your own. So here we have a triangle with our three angle measures. And if we take a look at the first one over to the far left, 61 degrees, we can see that the exterior angle is going to be 119 degrees because both of those are supplementary to each other. Now, the other angle up at the top, 79, the exterior angle will be 101 degrees because again, they are supplementary to each other, and 180 minus 79 is 101. And finally, we have a 40-degree angle, and the exterior angle will be 140 degrees. Now, if you notice, all those angle pairs form linear pairs if you want to take a look at it like that. And again, linear pairs, the two angles are supplementary to each other. So if you add all three of those numbers up, 119 plus 101 plus 140, you get the sum of the exterior angles for this triangle to be equal to 360 degrees. Like I said before, I'd like for you to go back and try to do the other three examples by yourself: quadrilateral, pentagon, and hexagon. Again, just find each of the exterior angles and then add them all up to find the sum of the exterior angles. That is the end of this video, the first video for polygons and quadrilaterals. I would like for you guys to try those and put those in those charts and have the notes ready for when we begin in class. I'll see you then.